And now we're moving on to 1.6, mathematical treatment of measurement results. So here we're going to explain the dimensional analysis or factor label approach to mathematical calculations involving quantities, and use dimensional analysis to carry out unit conversions for a given property and computations involving two or more properties. So this section is very, very important because you're going to be doing these types of calculations basically all throughout chemistry. Or at least through general chemistry. So this semester and next, you are going to have to understand how to do dimensional analysis and unit conversions. So quantities may not be that easy to measure directly, but we can get them from some other measured quantity and use a mathematical relationship to convert from one to the other. And this is called dimensional analysis. So this is based on the premise that the units of quantities must be subjected to the same mathematical operations as their associated numbers. And we're going to dissect what that means as we go along. So let's first talk about equivalencies and conversion factors. So a conversion factor is a ratio of two equivalent quantities that have different units. So for instance, 2.54 centimeters is equal to 1 inch. This is an equivalence. Okay, so 1 inch, don't mind my spelling, I am not an English major. So 1 inch is the same as 2.54 centimeters, but these are different units. So we can, let's say we want to solve for one of these. I want to solve for inches. So I divide both sides by 2.54. I'm just going to show you just a little thing. So if I divide both sides by 2.54 centimeters, then I know that 1 inch divided by, or per every 2.54 centimeters, is equal to 1. I could do the same thing by dividing both sides by 1 inch. And I still get that 1 is equal to 2.54 centimeters for every 1 inch. So these are our conversion factors. So remember, units can be multiplied and divided. So that's what we're doing here. So here's table 1.6. This has a bunch of different common conversion factors in it. So for instance, 1 meter is equal to 1.0936 yards, 1 quart to 0.94635 liters. So this is just a helpful table with some conversion factors that then, or equivalencies that you can then turn into conversion factors. So we have to use the form of the conversion factor that cancels out the unit we're trying to get rid of. So for instance, we want to convert 34 inches to centimeters. So I'm starting with 34 inches, and you can consider this as being over 1. So I have inches in the numerator, which means to get rid of them, I need to divide them out by putting them in the denominator. So then they cancel out to become 1. And then centimeters are what we're left with. Okay, so to do that, we need to use the conversion factor where inches are on the bottom and centimeters are on top. So that means we need the 2.54 centimeters on top and 1 inch is on the bottom. Now, one way that I found that some students liked when they're doing these types of calculations to set them up, it's the same thing as what we did here, just using kind of a box method, if you will. So you start putting 34 inches, make sure you put your units. And then we draw a little line here. And then we say, okay, I need to get centimeters. So I need to get rid of inches. So they cancel out. And then I go, okay, my conversion factor, that means 1's on the bottom, 2.54 is up top. And you can do this if you have multiple conversion factors. You just keep adding little lines and boxes. And then everything on top You multiply and then divide it by everything on bottom. Okay, before we move to temperature, let me go to a blank screen and let's do an example. And we're told the mass of a Frisbee is equal to 125 grams. And we want to convert to ounces. And one thing we're told is that 1 ounce is equal to 28.349 grams. So I'm starting with 125 grams. And I want to get rid of grams. That means it needs to go on the bottom. And ounces, that means it needs to go on top, since that's what I want to end with. So that way our grams divide out. And so, oops. Oh no. Let's try that again. 125 grams. Grams on the bottom, ounces up top. And we had that 1 ounce is equal to 28.349 grams. So since we want ounces on top, that means I need to divide both sides by 28.349 grams. Okay, so 1 ounce on top, 28.349 grams on bottom. So that simplifies to 125 divided by 28.349. And our number of significant figures, we have 3 and 125. And this 28.349 has 5. So it's going to be 3 significant figures. This 1 ounce, you can consider this an exact number. So our final answer, once we take into account sig figs and rounding, is 4.41 ounces. And let's do one more example. And we have a volume. Whoops. So I want you to, come on now. Might help if I turn my pen on. I want 9, doing this. Sorry guys. Try this again. 9.345 quarts. And I want to convert those to liters. So if we look at table 1.6, we're told that 1 liter is equal to 1.0567 quarts. Okay, my pen's being weird. Okay, so I want liters on top, which means quarts have to go on bottom. So we're going to divide both sides by 1.0567 quarts. So we're starting with 9.345 quarts. 1 liter up top for 1.0567 quarts. Again, that 1 liter is an exact number. So whenever you have like 1 is equal to blah, 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 the 1 is exact. But the other numbers, when you're going from metric to US, so metric to US are actually not exact numbers. There are a couple ones that don't count. So for instance, inches to centimeters, that is actually an exact number, fun fact. But all the other metric to US conversions are not exact. They are measured numbers. Okay, so we see quarts cancel out. And then we see 4 sig figs here versus 5. So 4 sig figs on our final answer. So then this should come out to be 8.844 liters. 0.844 Now we can also do another blank slide. We can use density as a conversion factor. So if you remember, density is equal to mass over volume. That looks kind of like a conversion factor, doesn't it? So let's say I want to know the density of common antifreeze in units of grams per milliliter, and I'm given a 4-quart sample and a weight of 9.26 pounds. Want density grams per milliliter. So we first need to convert our starting units to grams and milliliters. So we can start with our quarts, and let's do that to milliliters. One thing that you might notice is on our table, it doesn't give us quarts to milliliters, but it does give us quarts to liters. And then if you recall, we were told that how the prefixes, this is in 1.4, how prefixes change our base numbers. So milli is equal to 10 to the negative 3. So then that means that 1 milliliter is equal to 10 to the negative 3rd liters. It doesn't matter what our base unit is. This would be the same if it was milligrams versus grams. Okay, so then I can get rid of the liters by putting 1 milliliter over 10 to the negative 3rd liters. So you can see quarts cancel, and now liters cancel. Now your book breaks this down into individual steps. First it does quarts to liters, then takes that answer and goes to milliliters. That is perfectly fine too. It all will give you the exact same answer. So we have 4 1.0567 and we get 3,785 milliliters. Now, we can go ahead and change this for significant figures if we want right now, or we can wait till later, because we know our final answer should be 3 sig figs. Okay, so we can go ahead and just change this to 3 sig figs. We'll put it in scientific notation to make it a little easier. So 3.79. Okay, so 1, 2, 3 times 10 to the 3rd power milliliters. Now let's convert our weight to grams. So our table gives us a conversion that there are 453.59 grams per 1 pound. And with sig figs, that comes out to I gotta go on the next line. That comes out to 4.20 times 10 to the 3rd grams. So now we can plug these into density. So our density is equal to mass, 4.20 times 10 to the 3rd grams, divided by volume, 3.79 times 10 to the 3rd milliliters. And we're set up for 3 sig figs, and we get a density of 1.11 grams per milliliter. Okay, so this was a little bit more of an involved problem. These are good practice problems. These might be something that you should really study for the exams. So let's do another example. And let's say I want my volume in liters. This thing just loves giving me a hard time, doesn't it? Oh, nope, not that. Sorry, guys. Technical difficulty. Okay. So now I'm starting with my volume. I want volume. Gosh, why you do this? Okay, so I want volume in liters given 1.000 ounces, and then we're told that 1 liter equals 1.0567 quarts. And we're also told that 1 quart is equal to 32 ounces. And we told that this is an exact number. Okay, so let's look at what we're starting with, ounces. And based off of what we're given, we can go ahead and go from ounces to quarts. Okay, and we want ounces on the bottom. We need to get rid of it. So 32 ounces goes on bottom. Quarts goes on top. And then we can go from quarts to liters. And we're told 1 liter, we want that on top so we can get rid of quarts on the bottom. 1.0567 quarts on bottom. So once we plug all that into our calculator, we get 2.956 times 10 to the negative second liters. All right, let's look at another example. I'll have to clear all the ink since that seems to kind of mess everything up. Do it the old-fashioned way. All right, so while being driven from Philadelphia to Atlanta, a distance of 1,250 kilometers. Write down what we're given. A 2014 Lamborghini Aventador Roadster uses 213 liters of gasoline. And the first thing we want to know is the average fuel economy in miles per gallon did it get during this? And then what is the fuel cost? So part A, we want miles per gallon. So the first thing we need to do is some conversion. So let's convert our kilometers to miles. That's our distance equivalent. So we have 1,250 kilometers. And from our equivalency table, we find that there are 0.62137 miles for every 1 kilometer. Kilometers cancel. And we get 777 miles. Okay, 3 sig figs. This 0 in the 1,250 is not significant. Okay, so it's only 3 sig figs. And then we need to convert our volume from liters to gallons. So we look at our table and we find that we can go from liters to quarts and then from quarts to gallons. So there are 1.0567 quarts per 1 liter. And then we see our liters cancel. We want to get rid of quarts and end with gallons. And there's 1 gallon for every 4 quarts. And the gallons and quarts is an exact number. So our final answer is going to be 3 sig figs. That's 213 liters. So we calculate this all out to get 56.3 gallons. So our average fuel economy, okay, So mileage is in terms of miles per gallon, right? So we're going to take our miles, 777 miles, divided by our gallons, 56.3 gallons. And that gives us 13.8 miles per gallon, or MPG. Oh, that just makes me shudder. I drive a plug-in hybrid, and it's an SUV, so it gets 40 MPG overall. And that's still, to me, could be better. I used to drive a Prius that got 60-something. But living in the high desert, I wanted a better SUV. All right. So then part B, we're told gasoline costs $3.80 a gallon. What is the fuel cost for this trip? So we're told $3.80 per gallon. So we can make that into a conversion factor. So we have $3.80 for every 1 gallon. And we know that we went 56.3 gallons. So that's how much we use. 56.3 gallons times $3.80 per 1 gallon. So this trip cost $214. You definitely don't buy a Lamborghini for the fuel economy. There is another example here that's pretty much the exact same, but using a Toyota Prius. I will let you guys do that on your own if you'd like to, because we've already done a lot of examples. But again, if you have questions, just let me know. Okay. So now let's talk about converting temperature unit. So temperature refers to how hot or cold something is. It's a way to measure the amount of heat in something. We use thermometers, usually alcohol thermometers. We don't really use mercury thermometers anymore because dangerous. And it can either go up or down depending on the temperature. And if it changes, so will the reading. Now, there are 2 scales that are very common. Those are Celsius and Fahrenheit. Celsius being what pretty much everyone in the world uses except for the good old US of A. And it specifies that at 0 degrees Celsius is where water freezes, and it boils at 100 degrees Celsius. Oops. Now, the Fahrenheit scale, this is what we use in the US, specifies that water freezes at 32 degrees Fahrenheit and boils at 212. So if we want to convert between Celsius and Fahrenheit, we have some equations. So let's say you want your Fahrenheit temperature and you know Celsius. It is equal to 9/5 times your temperature in Celsius plus 32 degrees Fahrenheit, plus 32. So that's Fahrenheit. Okay, for Celsius is equal to 5 times your Fahrenheit temperature minus 32, all of that divided by 9. Your book talks about using this by plotting a graph. I'm not going to bother with that, but if you're interested, you can look into that. Now, the SI unit of temperature is the Kelvin, and it is an absolute temperature scale. There are no negative temperatures. So 0 Kelvin corresponds to the lowest temperature that can theoretically be achieved. Not that it can be or that it ever has been. So water freezes in the Kelvin scale at 273.15 Kelvin, and it boils at 373.15. Notice it's a 100-degree difference, just like Celsius. So a 1 degree difference in Celsius is the same as a 1 Kelvin difference. So here's just a summary of your formulas to convert. The top one is for Fahrenheit and Celsius, and the bottom one is for Kelvin. I talked about Kelvin earlier. Take your degrees Celsius, add 273.15. And this is just a visual image to kind of show you some points on it and how the scales compare. Okay, so that ends chapter 1. This last picture here is kind of just a way to look at some accuracy versus precision. I leave you with this to look at and think about. Archer W seems pretty accurate, not precise at all. Archer X, precise, not accurate. Archer Y, neither. Archer Z, neither. So we went through a lot of stuff. Please make sure to do your homework and take the quizzes that are on Canvas. There's also lots of practice exercises in your book that will help you as well with studying and getting some good practice. Please know if there's something you need me to go over, you can email me, you can text me, you can post in the Q&A forum. Anything is fine. I will do my best to answer any questions you guys may have. That being said, I will see you all soon.